Okay, good morning, everybody. This is Miss Nelson here. I am out of the building today, but we still have some math to do. So you should be looking at this page of notes. It says checking solutions to a system. These notes should be taped into your notebooks. So if we haven't done that yet, we can pause the video here to make sure the taping has happened. Okay. So I'm going to do a really quick example of how we check solutions to a system of equations. This is very similar to a skill we learned last unit, and it corresponds with the questions on page 7 in your unit packets. So let's do this example. It says, for each ordered pair, determine if it is a solution to the following system of equations. And then our system is right here. So we've got 4x plus 8y equals 48, and y equals 3x plus 6. That's our system of equations. So the first thing to know is that when I'm checking a solution, I need to check if the point is a solution for both equations, okay? So I have to check for both. What I'll be doing is, here's the points it wants me to test, these 3 points right here. Each one I will plug into the first one and see if it works, see if it makes a true statement, and plug into the second one as well. I have to check both. So let's start with this first one right here. Also, let's make this the red one and this the blue one so we can keep track of what we're doing. Okay, let's start with this point, -2, 0. We're going to check if that is a solution to this system of equations. So we have this point, -2, 0. Let's start by checking it in the red line. That's 4x plus 8y equals 48. Okay, first of all, with coordinate points, they always write the x coordinate first and then the y. So we'll go ahead here and plug in. For x, we'll plug in -2 plus 8. And for y, we're going to plug in that y coordinate of 0. Okay. 4 times -2 is -8, plus 8 times 0 is 0, and -8 plus 0 is -8. And we get all the way down to here, and we get a statement that's basically nonsense that says -8 equals 48. Okay? That is definitely not a true statement. And it's really even easier to tell that it's not true than it was last unit, because we had to check, okay, is it greater than or equal to? Here it's just simply -8 does not equal 48. So for this one, we can go ahead and say no. -2, 0 is not going to be a solution to this system of equations. And I don't even have to go check the other one, because once I got a false statement on this one, it's not going to work. I need both to be true in order to be able to say that yes. So in this case, we have no. -2, 0 is a no. Let's skip ahead to 0, 6. Let's check that one. So I'm going to sort of box this off. Okay, we're going to check the next point, which is 0, 6. And again, let's start with this red line, 4x plus 8y equals 48. Okay, here we have an x coordinate of 0 and a y coordinate of 6. So I'll go ahead and take my x coordinate of 0 and plug it in for x right there. And And I will take my y coordinate of 6 and plug it in for 6 right there. Okay, 4 times 0 is 0, plus 8 times 6 is 48. And I get a statement that says 48 equals 48. And that is true. So far so good. Okay, so far this point 0,6 is a solution to this line. Okay, but I'm not done yet because this is a system. So now I need to check the blue line. So now I need to check the same point 0,6, but I need to check it in the blue line. And the blue line says y equals 3x plus 6. Okay, so let's do it. Same process, but now with the other line. Okay, I've got a y coordinate of 6, so I'll plug it right in there for y. Equals 3 times, got an x coordinate of 0, so that's going to go right there. Okay, 3 times 0 is 0, and 0 plus 6 is 0. And I get 6 equals 6, which is indeed true. Okay, so I just checked both lines, this first line and this second line, and both of them I ended up with a true statement. So we can conclude that yes, 0,6 is a solution to this system of equations. Okay, this is a lot of skills you already know. Checking points. Just make sure to check both equations. Okay, that's the most important thing here. Other than that, you're just plugging in numbers and doing order operations. Okay, so pause this video to let students finish writing in this section of the page. And now we're going to go on to this bottom section. So this is another skill that a lot of us already know, writing a system of equations from a graph. Because a lot of us already know how to write like a line from a graph. This is as simple as doing that skill, but 2 times. So this corresponds to pages 8 to 9 in your unit packet. Okay, so what's going to happen in these kind of problems is you're going to be given a graph and asked to write lines. So how are we going to do that? Well, it says to write a system of equations, look at each linear equation separately to determine the slope and y-intercept. Then use y equals mx plus b form to write the equation of each line. Like really, if I want to use this form, y equals mx plus b, all I need to know is the slope and the y-intercept, and I'm done. Then I can write an equation. So we just need to identify those things, and we're going to practice with this problem right here. So this problem says, write a system of equations from the graph below. Okay. First of all, I'm going to make this line red and this line blue, just so we can kind of keep track of what we're doing. So let's start with the red line. So for the red line, what's my y-intercept? What's my b? Or in other words, my y-intercept? Okay, well, the place that the line crosses the y-axis is right here at -4. See that? So I've got a y-intercept of -4. And what about my slope? How do I find a slope? Well, I like to find it, there's many ways you could find it. I am going to find it right now by simply jump counting between points. Remember that the slope is just rise over run. So if I can figure out the rise and figure out the run, I can write the slope. Okay? So for this red line, I'm going to start at this point and end at this point. And the reason I picked those points is because this point is nicely right on like a crosshair or like a corner where I know exactly the value of this point. And same thing with this point. And the last thing I'll say before we just jump count here is that like we read graphs from left to right just like we read books. So when I'm jump counting, I'm gonna start at the leftmost point and head towards the rightmost point. You can do it the other way also, but that's how I like to do it. I like to keep it consistent that way. And I would recommend that method for now. Okay, so we're gonna start here. We're gonna jump count. How much up do we have to go to get to that next point? 1, 2, 3. Okay, we got a rise of 3. And then how far over do we have to go? Well, we're going positive 1. So we got a rise of 1. And that gives us a slope of 3. So we'll simplify 3 over 1 to just be 3. And, I forgot what I was going to say. Okay, maybe it'll come back. Okay, so now we can write our equation. So remember, we have equations like y equals mx plus b. And if I want to turn this red line into an equation that looks like this, all I need to do is plug in my slope of 3 in for m and my y-intercept of -4 in for b, and I get this beautiful equation. That's the one for the red line. Done. Okay. All we need to do is repeat that process one more time for the blue line, and we're done with this problem. Okay. Pause the video at this point if need be. And now we're going to find both the y-intercept and the slope for the blue line. Okay. Well, my y-intercept is right here. This is the place where the blue line is crossing the y-axis. So I have a y-intercept of positive 3. Oh, I remember what I was going to say earlier. Okay, when you head this direction, we're heading positively. When you head this direction, we're heading negatively. A lot of you already know that, but that's why, like, this jump here, I know that's a positive one and not a negative one, because we're heading this direction. Okay, let's determine the slope of the blue line. Again, let's pick a couple points to count between. Let's pick this point here and this point here. These points are just kind of nice because, again, they're like right on a corner, right on a crosshair. I know exactly the value of these points. Okay, so what's my rise? And again, we're gonna start at the leftmost point and head to the rightmost point. And our rise is actually gonna be, we're going down 1. So we have a rise of -1. So let's add that over here. So we have our top of the fraction is going to be -1 because we went down 1. And we're going to jump count over now. So we're going to go over 1, 2. So then the bottom of the fraction of the slope, the run, is 2. So I get a slope of -1 over 2. Okay, now I just need to write my equation. And again, I have this format right here, y equals mx plus b. All I need to do is plug in for m is going to go my -1/2 slope. And in for b is going to go my +3 y-intercept. And now this problem is done. I started with 2 lines on a graph, and now I have this system of equations. Okay, that's all for me today. I will miss you all, and I will see you next week.